and welcome to the session Introduction to 3D Modeling and Texturing. Today we will discuss three-dimensional designs and introduction. Animation is a type of optical illusion. It is the process by which we see still pictures move. Animation is an art form which can come from anywhere and which can go to anywhere. The word animate comes from the Latin verb animare, meaning to make alive or to fill with breath. We can take our most childlike dreams or the wackiest worlds we can imagine and bring them to life. It involves the appearance of motion caused by displaying still images one after another at the rate of 24 pictures per second. The eye can be fooled into perceiving motion when these consecutive images are shown at a rate of 24 frames per second or faster. Animation precedes the invention of photography and the cine camera by several decades. It is an art form in which a world of dynamic image and sound may be synthesized completely out of nothing but a thought. In animation, we can completely restructure reality. We take drawings, clay, puppets or 3D forms on a computer screen and we make them seem so real that we want to believe they are alive. Animation has the capacity to entertain, exaggerate, simplify, abstract, reveal complex processes, visualize data, be a vehicle for humorous writing, etc. Film, television, advertisements, games, medical fields, corporate sectors, etc. uses the possibilities of animation. Now we'll look into 3D animation. 3D animation is the creation of moving pictures in a three-dimensional digital environment. This is done by sequencing consecutive images or frames that simulate motion by each image, showing the next in a gradual progression of steps filmed by a virtual camera and then output to video by a rendering engine. Computer gives the opportunity to the animator to use time, technique and creativity at a higher level and enables high-quality products to be emerged. One of the most obvious differences between 2D and 3D animation is the appearance of depth or the three-dimensional features. 2D animation is flat animation where all the actions happen in X and Y axis. On the other hand, 3D animation involves extra dimension, that is the Z-axis. Traditional 2D animation is a procedure where images are hand-drawn with every image showing some subtle changes from the other image. These images, when played back in a sequence, create an illusion of movement. When it comes to 3D animation, everything is carried out with the help of the computer and even exported through the computer. 3D animation is generated by changing the placement and the poses of the 3D models that have already been created. Generated scene can easily be viewed from a number of angles. Let us look into the history of 3D animation. 3D animation is one of the modern improvements on a working industry. Old-fashioned two-dimensional cartoon animation has largely been done away with in special effects of modern films which favor a more realistic computerized image. Hence, 3D takes the stage to suck the viewer into a virtual world that is seemingly more like our own. Man has always possessed the ability to draw in 3 dimensions. But when did this avenue of creativity launch into the world of computers? There were many movies that pioneered computer animation, and it was William Fetter, an employee at Boeing Corporation, who first coined the term computer animation in regards to his line of work in 1960. In 1971, the Andromeda strain showcased the first computer-rendered image in a movie, though not animated in pure 3D. Future World, a 1976 science fiction film, which was the first or one of the first to display 3D CGI, that is computer-generated images in a feature film. Toy Story took the industry to another level in 1994 when it released its full-length CGI movie, a never-before-completed feat. These films were hailed as technological marvels of their time. Since then, computerized animation has become a thing we have come to expect of major blockbuster movies. So, what are we to expect of the future of 3D animation? Well, many consider the pinnacle of long-term CGI to be the display of photorealistic humans. Thus, we can make humans look as if we are doing incredible feats when in all actuality we are simulating such examples. However, due to a general negative public reception towards realistic-looking simulations, also known as uncanny valley, progress may be slowed. We are left with two branches of 3D animation, non-photorealistic and photorealistic rendering. In other words, those who work on CGI to imitate and look like real life, such as Final Fantasy, Spirit Within, and those who work on CGI to produce a cartoon, such as The Incredibles. Regardless of the opinions of individual cartoonists, there will eventually be one day when photorealistic 3D animation will have reached its climax. Until then, we have amazing special effects that can nearly simulate all kinds of imagery. From the 50s well into the 2000s, we saw the birth of an industry that has taken entertainment to a new level. Games, movies and television shows all have benefited from the work of a few men have done for technology, and we will still continue to see their legacy evolve. Now, an introduction to 3D softwares. In recent years, 3D animation has become popular with more and more professional animators opting to do 3D work, either in films or for short videos. It can be a great way to truly show off your talents as a digital artist. 3D animation is slowly but surely becoming the norm, with many of the leading production companies all over the world setting the bar high in terms of animation quality. We will be examining some of the more obvious choices for professional animators and exploring some of those applications. Sidefx Houdini. This tool is known as the mother of animation tools. It has been used in movies, games, commercials and personal projects by big and small companies alike. Houdini has a very strong particle and smoke system due to its powerful animation and VFX tools, and its lighting effects are also pretty decent. Companies such as DreamWorks Animation, Blue Sky Studios, Image Engine and Axis Animation use this tool. Next, Autodesk 3D Studio Max. 3D Studio Max is another well-recognized name within the industry. This software is commonly used in video game development and has been used in the product of well-known games such as Grand Theft Auto and GameCube 3D. Studio Max is also starting to be used more and more in film productions, as it has powerful controls over dynamics and shading as well as realistic lighting. Next, Autodesk Maya. For the next level of users, Autodesk Maya is something that presents outstanding opportunities for animation work. A great deal of the work we see on our cinema and TV screens has been produced via Autodesk Maya, including Spider-Man, Lord of the Rings, to name but a few. Autodesk Maya is an extremely powerful software tool, and even top 3D animators continue to learn and progress their skills from using it. Autodesk Maya will take you through the full 3D effect spectrum, from a world of paint effects, rendering and a plethora of animations. Next, Maxon Cinema 4D. Maxon Computer GmbH has introduced revolutionary 3D software to the market. This product gives you options and resources for advanced character tools, physics engines, hair, eyes and an unlimited network for rendering. It is also capable of procedural and polygonal sub-D modeling, lighting, rendering, texturing, animating and other common features you will find in 3D modeling software. Blender. It was released in 1995 by the Blender Foundation. It was created for everyone and was released as free software for animators. Their site is also full of resources for beginners and experts, and the community is warm and friendly with a lot of great insight and tips. Gallery of other Blender render movies, commercials and games uses the Blender software. Spider-Man 2, History Channel and more used this software in planning and animating certain scenes, giving it a great start for an international foothold. The Blender Foundation themselves also created open projects in animation and gaming. One of their favorite 3D animation open projects was Big Bug Bunny and the game Yo Frankie, showing exactly what you can do with the game engine. Now let us look at Autodesk Maya in detail. Autodesk Maya is an animation and modeling program used to create three-dimensional full motion effects. Autodesk Maya incorporates the natural laws of physics to control the behavior of virtual objects in computer animation. It can produce videos that are more lifelike than has been possible with less sophisticated programs. Versions are available for both IBM compatible and Macintosh operating systems. Until the development of Autodesk Maya, realistic rendering of certain natural effects such as smoke blowing in a breeze, the rotation of clouds and dust in a tornado, or the sag and movement of clothing caused by gravity was difficult or impossible to achieve. In addition to simulating the movements of objects and particles, Autodesk Maya makes it possible to portray emotions in animated characters by enhancing facial expressions and the realism of body language. Some technical people at animation studios have begun taking courses in Autodesk Maya. The robots in the movie Transformers, the spectacular special effects in the latest Star Trek movie, and the magical creatures in the Harry Potter movies all have one thing in common: Autodesk Maya 3D. This high-end 3D modeling, animation, visual effects rendering and compositing software brings TV, movies and games to life. Autodesk Maya is used by all the major commercial animation houses. Most do not depend on it exclusively, but Autodesk Maya and MEL are valuable skills to have. It is extremely powerful but also extremely complex. It has a steep learning curve. In general, there is more than one way to do anything in Autodesk Maya. During the 1980s and 90s, the three companies leading special effects and 2D and 3D modelings were in different countries. California-based Wavefront had advanced visualizer, while in France Thomson Digital Image TDI owned Explore. In Canada, Alias created animation with Power Animator. Wavefront purchased TDI in 1993. That same year, Alias started developing a new animation tool called Maya, Sanskrit for illusion. In 1995, Alias and Wavefront merged into one company when Silicon Graphics Incorporated bought them both. The merged companies wanted a combined software system for digital content creation. They called the company Alias Wavefront and focused on creating Maya. With Hollywood on its mind, Alias Wavefront spent 2 years developing Maya. Beta testers for Autodesk Maya included a who's who of the film industry: Blue Sky, Ronda Graphics, MPC Studios, Weta, ILM, Pixar Studios, DreamWorks Animation, Prime Focus and Santa Barbara Studios, to name a few. Released in 1998, Maya quickly became the film industry standard, with Industrial Light and Magic buying enough copies for its artists and technical directors to use it extensively. Blockbusters such as Star Wars Episode 1, The Phantom Menace, The Mummy, Shrek, Spider-Man and The Lord of the Rings used Maya to create special effects. On March 1, 2003, the Academy of Motion Picture Arts and Sciences presented an Oscar for scientific and technical merit to Alias Wavefront for creating Maya. In October 2005, the parent company of Alias Wavefront sold the company to Autodesk, which renamed it Autodesk Maya. Founded in 1982, California-based Autodesk focuses on entertainment, engineering, 2D and 3D design. Now, Autodesk celebrates their victory with Autodesk Maya 2016 version. Now let us look at Autodesk Maya features. Autodesk Maya provides the rampant human imagination with an infinite sandbox to play in. You can create 3D characters, scenery and animation of cinematic quality that are perfect for movies, games and broadcast television. Its emphasis is on customizable workflow and the many built-in features for simulating lifelike characters. No other product on the market provides an equal spread of features. Make no mistakes, the learning curve is very steep. Nevertheless, if you have the patience and motivation to learn. Now we look at modeling. There are 4 distinct camps in the model building universe: polygon, subdivision, NURBS and sculpting. Each modeling style comes with pros and cons. NURBS, for example, uses Bezier curves to create meshes which are ideal for simulating mechanical parts and smooth surfaces. Unfortunately, they are also harder to manipulate and have a reputation for not playing nice when building organic characters. Autodesk Maya supports all 4 methods, which really opens doors for expert modelers. You can select the methodology that best fits the needs of each creation on an individual basis. Beginners can start polygon modeling with a wide array of primitives that can be squished, scaled and extruded to obtain the desired form. Once you have the basic shape and structure of your model, Autodesk Maya's soft selection tool and sculpting brush give you fine-tuned control over the critical details. These features are just the tip of the iceberg. Autodesk Maya is stuffed to the gills with modeling tools large and small. With the scene assembly tools, you can manage your production assets with even greater ease. You can easily swap between representations, which help you create large, complex worlds in an organized manner. We'll look at textures and materials. Autodesk Maya gets its name from the Hindu concept of illusion, and it lives up to the moniker very well. No matter how detailed and intricate your 3D mesh may be, your illusion will be incomplete without realistic texture and color, especially if you plan to stitch your creation into real-life video footage. Fortunately, Autodesk Maya offers great texturing features and even better materials and physics to give your models that sense of mass and realism. UV texture maps are a well-known and efficient means of coloring your models. You can create textures externally to Autodesk Maya, or you can generate them with a paint tool within the application. The result is an image file that folds around the model like a skin. You can add actual texture with a bump map. Like the UV map, a bump map generates topography on the surface of a model by drawing data from a skin-like image. Dark spots will produce valleys and white spots produce peaks. Autodesk Maya's many material simulations are extremely attractive. Now, animation features. Rigging is the complex process of adding a bendable skeleton to your models. This 3D animation software supports IK, that is inverse kinematics, and FK, forward kinematics, and it allows for easy switching between the two. IK allows you to tug on one part of your model and have other parts come along for the ride. FK does the opposite. It allows you to move one part of your model and have it push the other connected parts. With both types of skeletal control, you can create realistic motion patterns that will come in handy in the animation phase. Autodesk Maya also features pose blending, which allows you to adjust your skeleton into several different poses and use a slider to modulate between them. This is especially ideal for animating facial expressions. Autodesk Maya really shows its grit when it comes to animation. It supports scripted animation, keyframe animation and procedural animation. You can animate in separate layers, dub your animation with multiple audio tracks, and even render your animations in stereoscopic 3D. Apply motion capture data to your character models and splice models into existing footage with a motion tracking feature. Slow down or stop the timeline for metrics-like effects with the time warping feature. Edit the motion trails of objects for easy adjustment of your animations. Copy movement patterns from one character to another with the Maya exclusive animation retargeting function. The list of animation features could go on and on, but you get the idea. This 3D animation software is a powerhouse. Now into Maya Dynamics. Dynamics is a branch of physics that describes how objects move. Dynamic animation uses rules of physics to simulate natural forces. You specify the actions you want the object to take, then let the software figure out how to animate the object. Dynamic animation lets you create realistic motion that's hard to achieve with traditional keyframe animation. Special effect animation simulates not only physical phenomena such as smoke and fire, but also the natural movements of colliding bodies. Behind the latter type of animation is the Maya Dynamics engine, which is the sophisticated software that creates realistic looking motion based on the principles of physics. Another Autodesk Maya animation tool, Paint Effects, can create dynamic fields of grass and flowers, a head full of hair, and other such systems in a matter of minutes. Autodesk Maya also offers dynamic simulations for hair, fur, and cloth. Rendering in Autodesk Maya. Rendering refers to the final output of a model or an animation where Autodesk Maya produces a still bitmap image, a series of bitmap images, or a movie. Rendering produces images that take into account shading and textures, lighting and shadows, cameras and animation, the rendering method, visual effects. Rendering produces output that cannot be edited in 3D space any longer. You can think of rendering as if you are taking a picture or a movie of your 3D space and the objects in it. The rendered images can be edited in an image editor or a movie editor. The final output of the rendering process can be any number of file formats. For single frame rendered images, the output can be TIFF, JPEG, TARGA, etc., while for animations, the final output can be a QuickTime movie, an AVI, or a series of single frame images that can be put together in a movie editor. Autodesk Maya can use either software rendering, hardware rendering, Mental Ray, Arnold, or another third-party rendering engine. Autodesk Maya gives powerful platform for calculating global illumination, caustics, ray tracing, etc. Now let us look at types of modeling techniques. The first one is spline modeling. Spline modeling has also been referred to as patch modeling and allows a curve to be created with the use of two control points. These points are created in multiples to create the skeletal system of the model. This form of modeling is best for objects that are not going to be animated, as they require a lot of modifications to be suitable for the animation process. Cars, furniture, and real estate models are examples of which types of models work best within the spline modeling process. These types of models require an extensive amount of curved shapes and therefore work best with spline modeling. Next, polygonal modeling. This technique involves use of triangles, cubes, hexagons, and other shapes. Polygonal modeling is an advanced approach towards creation of 3D models for movies and video games. It's a very good technique to give an image a realistic appearance. However, it's important to determine the numbers of polygons one needs to use for a specific 3D image. The higher the number of polygons used, the smoother and realistic the 3D model is. However, it makes more sense to use millions of polygons for movies rather than games, since they have to be more efficient. This is the reason gamers use various techniques to reduce the number of polygons in 3D models so that they can run more smoothly and download quickly. A disadvantage of using polygon modeling is improper representation of curves and complexities in creating surface topology. Polygonal modeling opens avenues for transforming a primitive 3D mesh such as a cube, hexagon or cylinder into a 3D model. You can use a fewer polygons in an image to create a mesh of polygons and later add refinement to it. Polygonal modeling, without a doubt, is the most used technique among 3D game developers. Next, NURBS modeling. Unlike polygonal modeling, NURBS, that is non-uniform rational B-spline modeling, allows artists to create smooth curves and surfaces in 3D models. However, a 3D game artist has to be very smart when using NURBS modeling, as a 3D image can't be altered once it is created. An artist can create a NURBS surface by using 2 or more curves in 3D space. Control vertices allow manipulation along the X, Y or Z axis. This technique is not very popular for games and films and is commonly used for engineering and CAD. NURBS is known for versatility, precise design and speedy creation of 3D models. With NURBS, it becomes easier to edit, enable accurate data transfer and integration with many programs to create high-quality designs and models. Control points, not vector and functions are important terms to know for 3D game developers to use NURBS. Next, subdivision modeling. The mix of polygonal modeling and NURBS is called as subdivision modeling. This hybrid technique involves creation of a 3D model via polygonal model and then converting it into the subdivision model. This technique helps artists control the refinement of the 3D model in particular areas and easily transfer models between different software. A developer needs to subdivide and refine until polygonal detail is good enough to display the intended 3D model. The more you subdivide a surface, the smoother it becomes. To summarize, animation is a type of optical illusion. It is the process by which we see still pictures move. In animation, we can completely restructure reality. It involves the appearance of motion caused by displaying still images one after another at the rate of 24 pictures per second. 3D animation is the creation of moving pictures in a three-dimensional digital environment. This is done by sequencing consecutive images or frames that simulate motion by each image showing the next in a gradual progression of steps filmed by a virtual camera and then output to video by a rendering engine. One of the most obvious differences between 2D and 3D animation is the appearance of depth or the three-dimensional features. 2D animation is flat animation where all the actions happen in X and Y axis. While on the other hand, 3D animation involves extra dimension and it is the Z axis. There were many movies that pioneered computer animation, and it was William Fetter, an employee at Boeing Corporation, who first coined the term computer animation in regard to his line of work in 1960. Future World, a 1976 science fiction film, was the first to display 3D CGI in a feature film. Toy Story took the industry to another level in 1994 when it realized its full-length CGI movie. There are different softwares used to create three-dimensional designs like Sidefx Houdini, Autodesk 3D Studio Max, Autodesk Maya, Maxon Cinema 4D, Blender. Autodesk Maya is an animation and modeling program used to create three-dimensional full-motion effects. Autodesk Maya incorporates the natural laws of physics to control the behavior of virtual objects in computer animation. It can produce videos that are more lifelike than has been possible with less sophisticated programs. Autodesk Maya provides the rampant human imagination with an infinite sandbox to play in. You can create 3D characters, scenery and animations of cinematic quality that are perfect for movies, games and broadcast television. Its emphasis is on customizable workflow and the many built-in features for simulating lifelike characters. There are different types of modeling techniques that support Autodesk Maya. Spline modeling has also been referred to as patch modeling and allows a curve to be created with the use of 2 control points. Polygonal modeling is an advanced approach towards creation of 3D models for movies and video games. This technique involves use of triangles, cubes, hexagons and other shapes. Unlike polygonal modeling, NURBS modeling allows artists to create smooth curves and surfaces in 3D models. The mix of polygonal modeling and NURBS is called as subdivision modeling. This hybrid technique involves creation of a 3D model via polygon model and then converting it into the subdivision model. Autodesk Maya offers great texturing features and even better materials and physics to give your models that sense of mass and realism. Rigging is the complex process of adding a bendable skeleton to your models. Dynamic animation uses rules of physics to simulate natural forces. Rendering refers to the final output of a model or an animation where Autodesk Maya produces a still bitmap image, a series of bitmap images or a movie. Autodesk Maya can use either software rendering, hardware rendering, Mental Ray, Arnold or another third-party rendering engine. Autodesk Maya gives powerful platform for calculating global illumination, caustics, ray tracing, etc. Now, you may try to solve the given assignments. Prepare a paper on the principles of animation. Organize a group discussion among your friends on the topic, the importance of applying principles in animation. Prepare a lecture on the workflow of 3D animation. Model different cartoon characters using natural clay or plasticine. Create a story for a 2-minute animation short. I can suggest some books and web links for your further studies. Animation from pencils to pixels, classical techniques for the digital animator, written by Tony White, printed by Focal Press UK in the year 2006. Computer animation, written by John Hallas, printed by Focal Press UK in 1974. Toy Story, The Art and Making of the Animated Film, written by Steve Daly and John Lasseter, published by Hyperion US in the year 1995. Digital Modeling, written by William Vaughan, published by Pearson Education USA in the year 2012. Introduction to Computer Graphics and Creative 3D Environments by Barry Blundell, published by Springer, London in the year 2008. Art of 3D, Computer Animation and Effects, 3rd edition, written by Isaac V. Kerlow, published by John Wiley and Sons, New Jersey in the year 2002. And that is the end of this session. See you later. Until then, bye.